Here's the question then, differentiate these. So let's have a look at it. So we'll let y equal here, through all four of them, y equals and y equals. So part A, do y dx then. Something to the 5, use the function rule then, 5 power rule comes down of the something to the 1 less, multiplied by the something differentiated, 0 minus 18x. So that equals minus 90, 5 18s are 90, x times 7 minus 9x squared to the power 4. B, here we've got that. Arctan goes to 1 over 1 plus the something squared. So dy dx equals 1 over 1 plus the something squared. In this case is 6x squared multiplied by the something differentiated, which is 6. So that's 6 over 1 plus 36x squared. So that's part B. C, we've got a product here. Each constituent are themselves functions of a function. Dy dx then, product rule, u times dv dx, tan goes to sec squared of the something, multiplied by the something differentiated, which is 2. That's u to v plus v times du. E to the something differentiates to e to the something, multiplied by the something differentiated, which is 4. So that's what we've got then. So there's a 2e to the 4x common. And we've got a sec squared 2x, sec squared 2x. So we've taken out a 2e to the 4x here, plus, and we've taken out just that, so it leaves the 2 in here, tan 2x, isn't it? Okay. Right, I'm just thinking whether we could tidy this up a bit more or not. We could actually tidy it up because sec squared is 1 plus tan squared, isn't it? Let's just remind ourselves, sine squared plus cos squared equals 1. And then to get sec, we divide by cos. So that would be tan squared plus 1, wouldn't it? Sec squared. So we can use this identity here and replace this. And we'll see why I've done that in just a tick. Hopefully you can see it. Sec squared is 1 plus tan squared, so I can write the tan squared term first. Plus 2 tan 2x. And then I'll put the plus 1 at this end here. So this was 2e to the 4x. And this is just 1 plus tan x. Let's write it around the other way. Although it might be easier on the eye that way, it's not the way it's in the line above. Tan 2x plus 1 squared, which equals 2e to the 4x. Now let's swap it around. 1 plus tan 2x. So we could tidy it up like this if we wanted, because that looks slightly easier on the eye. So that was tan 2x squared plus 2 tan x plus 1 squared is 1. So we could have done, but I'm quite happy with that, to be honest with you. But I just thought it might just look slightly better like that. So that's part C. Now part D then. 3 plus sine x over 2 plus cos x. That's a quotient, u over v. 3 plus sine x over 2 plus cos x. Let's just write that again. So here for D, dy dx, then use the quotient rule. V times du dx, this differentiates to cos, minus u, more than one term, put a bracket, times the VDX. Cos goes to minus sine all over V squared. Or this object squared. So what have we got? We've got 2 cos x on the top here, plus cos squared, and then plus a sine squared. Plus, so I'm going to leave that for now, 3 sine x. And then we've got a cos squared plus a sine squared, which is 1 over 2 plus cosine x squared. So I think that's the best way to write it. That's D.